Welcome to our comprehensive exploration of Retrieval Augmented Generation, or RAG. This revolutionary approach is transforming how AI systems access and utilize information, bridging the gap between static knowledge and dynamic, up-to-date responses. But what exactly makes RAG so special? Let's start by understanding what RAG really is. Our Retrieval Augmented Generation is a breakthrough that fundamentally changes how AI systems work. Unlike traditional models that rely solely on pre-trained knowledge, RAG combines the power of retrieval systems with large language models. It actively searches through external knowledge bases to find relevant information, then uses that context to generate accurate, current responses. Think of it as giving AI a dynamic library card to access the world's information in real time. Now, you might wonder why we need this approach when we already have powerful language models. The answer lies in the limitations of traditional language models. While powerful, they can only access information from their training data, which becomes outdated quickly. They often hallucinate facts when uncertain, and updating their knowledge requires expensive retraining. RAG elegantly solves these problems by providing real-time access to current information, reducing hallucinations through factual grounding, and enabling easy knowledge updates without retraining. This makes AI systems more reliable, accurate, and maintainable. To truly appreciate how RAG achieves this, let's examine its architecture. The RAG architecture is elegantly simple yet powerful. When a user submits a query, it first goes to a retriever component that searches through vector databases and document stores to find the most relevant information. The retrieved context is then combined with the original query and sent to a large language model. The LLM uses this augmented context to generate responses that are both accurate and grounded in factual information. This pipeline ensures responses are always backed by retrievable sources. But how does the system know which documents are relevant? This is where embeddings come into play. Embeddings are the secret sauce that makes RAG work so effectively. These mathematical representations capture the semantic meaning of text in high-dimensional vector space. When documents are converted into embeddings, similar concepts naturally cluster together, making it possible to find relevant information through vector similarity search. Modern embedding models capture nuanced relationships between concepts, enabling remarkably accurate retrieval even when queries don't match exact keywords. This semantic understanding is what makes RAG so powerful. But where do we store these embeddings, and how do we search through millions of them efficiently? This is where vector databases come in. These specialized engines are the backbone of RAG's retrieval capabilities. Unlike traditional databases that store structured data, vector databases are optimized for storing and searching high-dimensional vectors at scale. They employ sophisticated indexing algorithms like HNSW and IVF to enable lightning-fast similarity searches across millions of embeddings. Popular solutions include Pinecone, Weaviate, and Chroma, each offering unique features for different use cases and scale requirements. However, before we can store documents in these databases, we face another challenge: how to break them into searchable pieces. Document chunking is where the art meets the science in RAG systems. Large documents must be split into smaller, manageable pieces that fit within model context windows. But it's not just about size. The chunking strategy significantly impacts retrieval quality. Fixed size chunking is simple but may break semantic units. Semantic chunking preserves meaning but requires more processing. Sliding window approaches provide overlap for better context continuity. The right strategy depends on your document types and use case requirements. Once we've built our RAG system, how do we know if it's actually working well? This brings us to evaluation, measuring RAG performance across multiple dimensions. We assess retrieval quality through precision and recall metrics. Are we finding the right documents, and are we finding all relevant documents? Generation quality is measured through answer accuracy, faithfulness to retrieved content, and coherence of responses. End-to-end metrics like RAGAs provide holistic evaluation frameworks. Regular evaluation ensures your RAG system maintains high quality as it scales. With all these technical capabilities, where is RAG making the biggest impact in the real world? The applications are transforming industries across the board. In customer support, RAG powers intelligent assistants that instantly access product documentation to solve problems. Legal teams use RAG to search through vast case law databases, finding precedents in seconds instead of hours. Healthcare professionals leverage RAG for medical literature review and diagnosis support, improving patient care with evidence-based insights. Enterprise knowledge management systems use RAG to make organizational knowledge accessible to all employees, breaking down information silos. The possibilities are virtually limitless wherever accurate information retrieval meets natural language generation. As we conclude our journey through RAG, let's reflect on what this means for the future. We've journeyed from understanding what RAG is, through its architecture and components, to seeing its real-world impact. Retrieval Augmented Generation represents more than just a technical advancement. It's a paradigm shift in how AI systems access and utilize information. By combining retrieval with generation, RAG delivers accurate, current, and verifiable responses that users can trust. Whether you're building customer support systems, knowledge bases, or research tools, RAG provides the foundation for more intelligent and reliable AI applications. The future of AI is not just about bigger models, but smarter systems that know how to find and use the right information. Thank you for joining us on this exploration of RAG technology.